Algebraic rational expressions are ratios or fractions that involve algebraic expressions in the numerator and or denominator. In simplifying rational expressions that are algebraic, we use the same methods that we do for working with numerical fractions. Here are some of the processes that we use in arithmetic to reduce fractions and to multiply and divide fractions. If my fraction is 6 over 9, I can divide top and bottom of this fraction by 3 to reduce it, or I could factor 6 and factor 9 into prime factors and cancel the same factor from the top as the bottom. If I have multiplication, I can also cancel divide top and bottom of any of the numbers by a common factor to reduce down, or I can prime factor them like I did in the first problem, and I'll do that because that'll match up better with what we're going to do in this video for algebraic expressions. If I prime factor each one of those numbers, here's what I'm left with, and now I can divide top and bottom by 2, top and bottom by 3, top and bottom by 2 again, top and bottom by 3 again, and I'm left with 5/8, or cancel the same number from the top as the bottom. And the third process from arithmetic that we use is in multiplying fractions. We need to change, or we can change this into a multiplication problem, multiplying by the reciprocal of the fraction we were dividing by. So our 6/15 divided by 8/25 can be written as 6/15 times 25/8. If I prime factor each one of these values again, divide numerator and denominator by 2, divide by 3, divide by 5, I end up with 5/4. These three processes are processes that we'll use in simplifying rational or algebraic rational expressions, in that we will factor the expressions and then reduce. Here's an example. For multiplication, if this is my multiplication problem, I can factor each numerator and denominator and then cancel like factors. In the first fraction, numerator factors down into x minus 4, x plus 2. The denominator into x plus 2, x plus 5. In the second fraction, the numerator factors into x plus 5, x minus 5, and the denominator into x minus 4, x minus 5. I have x minus 4 in the numerator and denominator, x plus 2 in the numerator and denominator, and x plus 5 in the numerator and denominator, as well as x minus 5. Everything canceled out, and we are left with 1. Something I want to mention before we go further is that we want to be careful not to try to cancel something like the x squareds. And the reason why is because this canceling action is from actually dividing those factors out, and they have to be factors. They have to be held together through multiplication. These are terms. The x squareds are terms. They cannot be canceled out because they're not factors. They're not multiplied by something else, so they cannot be divided out. Let me give you a practice problem. Pause the video, multiply these fractions together through factoring, and then come back to the video to check your answer. If I factor the numerator of the first fraction it factors into x minus 4 times x plus 3. The denominator into x minus 8, x plus 3. The second fraction's numerator, x minus 8, x plus 5. And the denominator, x plus 8, x minus 4. In the problem now, we have x plus 3 in numerator and denominator. We have x minus 4 in numerator and denominator. X minus 8 in the numerator and denominator. And I'm left with x plus 5 over x plus 8. Let's now look at a division problem. Just like in the arithmetic problem I did a little while ago, let's rewrite this as a multiplication problem where we multiply by the reciprocal of the fraction we're dividing by. And then let's factor. And since we have multiplication, we can divide top and bottom by the same expressions. X plus 4 with the top and the bottom. X minus 5 in the top and the bottom. It looks like that's all I can divide out. So I'm left with x minus 5 over x plus 5, x plus 4. Let me give you a practice problem. This problem will involve multiplication and division, so be careful to change your division into multiplication, factor properly, and reduce. So pause the video, multiply and divide these fractions by factoring, and then come back to the video to check your answer. If I prime factor the first fraction, the first numerator, x minus 5, x plus 1, the denominator, x minus 6, x minus 1. Let me back up. Let me rewrite this as a multiplication completely. Let's change this to a multiplication instead of division. Keeping this last fraction as multiplication. And now let's factor. The second fraction, x plus 4, x minus 1, x minus 8, x plus 1. The last fraction, x minus 8, x minus 2, and x minus 5, x plus 4. So the problem has been changed completely into multiplication. We factor down each numerator and denominator. Let's cancel the same values from the top as the bottom. X minus 5s, x plus 4s, x plus 1s, x minus 1s, x minus 8, and I'm left with x minus 2 over x minus 6. So again, when we're reducing algebraic expressions that involve fractions, we can use some of the same methods that we used in regular mathematics to do this. Be careful to factor before you cancel.